Hi there, and welcome back to the Complete C Sharp Masterclass. In the previous module, we had a look at how Solid gets implemented in terms of the code. We had a look at the different individual principles of Solid, like single responsibility, open close, list of substitution, interface segregation, and dependency inversion. In this module, we'll have a look at how we can go about implementing dry code, where we don't repeat ourselves and we make something reusable. So we'll start off again with seeing how the violation works, and then we'll have a look at how the application works. So let's jump into that and see. So over here we have a calculator, and it's a simple add, subtract, and multiply. We build the calculator in the violation class, and then we add the numbers, subtract, and multiply, and then print out those results respectively. Now, this again, we're seeing a lot of repetition here where we're basically handling certain functionality and then doing what we need to do based on that. So let's see how we can go about making this a bit more easy for ourselves, where we don't actually have to repeat ourselves. So here we go and create some sort of perform operation. Perform operation is a type that returns a response, and it takes in an input A, it takes in an input B, and it takes in a function that takes in an int and another int as two parameters, and it returns a response of int, and we call this an operation. And this operation acts on the two inputs that we've been given, and then we simply just log the operation and the name. So here we go say, hey, Mr. Operation, apply this to the input A and B and log this depending on what you've been given. So here now what we have is we have add, and now we can perform an operation that says, hey, we have A and B, pass this to the perform operation, and then let whatever the value of X and Y, basically just add them together. So this is how we go about implementing the function. So again, this is how we pass a function to a function. This is also known as a delegate. So a delegate is being able to pass a function to a function, or passing a function as a parameter to another function. So here we basically go and say X and Y. So these are the parameters X, this is the parameter Y, so these two values. And what this function does is it simply goes and says, here's X plus Y, we adding. And we do the same for subtraction. We go say X and Y, and then X minus Y. And again, just to be clear, this X and Y simply refers to the parameters of this. With delegates, an important thing to remember is delegates work in such a way that they just expect an input. They are non-named parameters. So this can be named anything. It's not just, doesn't have to be X and Y. It can be input 1, it can be input 2. Sorry, this, I think I built the instance. Let's just say no. This can be input 2. Yeah, input 1, input 2. The names doesn't necessarily matter. It's just a reference to the two input variables and what they're supposed to do. So yeah, if the X and Y thing is confusing, just know it's just a name for the inputs. So yeah, then this will just perform the operation, and the same goes for multiply. In this way, we can reuse the same functionality without having to repeat ourselves. This does add a little bit more complexity to the example, but it's there to illustrate the point. We should, by all means, try not to repeat ourselves. We should always try to be able to have one encapsulated service or function or class or even a library that can just do the work for us without us having to repeat ourselves. This saves us a lot of development time, it saves a lot of money and time for the company as well, and it also means faster time to market. And then we simply just build this and so forth, and all of this still does exactly the same thing. So if we go and see and run this now, so adding, etc, etc. So let's maybe just log in the different types. So in here we can just go and add a log here to say applying dry, so that we at least know where the difference is. So yeah, we can go see it's exactly the same input and output. The only difference is that we're able to reuse the same functionality without having to repeat ourselves over and over and over again. Yeah, so that's how you can go about implementing dry. Make sure to try and do it by any point that you can. Sometimes it can even just mean like taking common functionality that's being reused over and over, even like a console write line. We could create something like a logger that logs that and so forth. So where you do get a chance, try to extrapolate functions that are reused and maybe put them either in a method in the same class, or even move it outside of the class into its own class, where you can reuse that functionality over and over as you see it. This also forms part of like the single responsibility and open close. So yeah, that's try. So in the next module, we'll have a look at Yagni, and we'll look at how we can go about using that to implement really clean code, and yeah, just look at focusing on the key principles. Thank you so much for joining this module. I will see you in the next one.